So we can see the z-scores there, and R can also be used to calculate the mean, variance, and standard deviation for this particular sample of data. So if you were to type mean of capital X, it'll return the mean. VAR for variance of X, it'll return the variance, and SD for standard deviation, and it'll return that. So keep that in mind. Now let's assume that the heights are distributed according to the normal distribution with a mean of 66 and standard deviation of 2.5. We can have R randomly sample from this distribution. So let's create a sample of 100 draws. So we're going to call this sample of draws capital X100. So we're creating a new vector here, and we're going to do the less than sign in the dash. We're going to use the rnorm command, and we're going to ask it to take 100 draws from this normal distribution with a mean of 66 and a standard deviation of 2.5. So what this command is telling R is to take 100 polls from a randomly created normal standard distribution with a mean of 66 and a standard deviation of 2.5. And it's actually pseudo-random because R will use the current date and time as seeds to create the distribution, but we'll talk about that soon. Anyway, so now we've created this vector x100 that consists of the 100 poles from this distribution. So again, you can use R to find the mean of that, as well as the standard deviation of that. Again, your numbers might not match up with this, and that's fine. And we can see what a simple histogram looks like for this data. So we're going to say HIST, capital X100. And that'll open up in a pretty giant window, so you can go ahead and readjust that so you can still see your main workspace. Move it over here. And as I said before, when you do this on your computer, you're going to get different results, and that's because your random draw is different. So we can have the same draw by setting a seed. So if we say set.seed 100, and then you create a new vector that has polls from a seeded rnorm command. So we're going to say x100a, and we're going to say rnorm paren 100 polls with a mean again of 66 and a standard deviation of 2.5. Now if we find the mean of this, it should match that, which does match what's in the text. So that's great. And find the standard deviation of that. Oops. So there you go. As I said before, commands are case sensitive. So there you go. So now it found the standard deviation, and we can again do a histogram of that. And that looks pretty close to what's in the text. I could scale it differently by adjusting the window, but that's fine. R has a command for determining quantiles of data. So if you said quantile of x100a, then you could tell by this that, for example, the median value of the data would be 65.85. So now we're going to go ahead and do a distribution with a larger draw. So let's say set.seed 666, and we're going to call this zdraw. And once again, we're going to do the rnorm command. We're going to ask it for 20,000 polls or draws, and the mean is going to be equal to 0, and the standard deviation is going to be equal to 1. And we're going to find the mean of zdraw. Excellent. And once again, we're going to find the quantiles of this set of data, and we're going to tell it to look for the quantiles in zdraw, and then we're going to ask it for custom probabilities of the quantiles. So we're going to say the probabilities of, and then we're going to use that C command again. So prob space equal to C, and we're going to do 0.01, 0.05, 0.5, 0.95, and 0.99. And so you can compare this draw with the theoretical values for our requested percentiles, which should be respectively negative 2.326, negative 1.645, 0, 1.645, and 2.326. And then we can do a density plot of the large draw too. So let's do a plot. And again, this is when you're going to use a nested function. So you're going to use the plot command paren and then density to ask it for a density plot of what? Of zdraw. And I spelled density wrong, and that's fine. And there's the density plot.